Hey everyone, welcome to this explainer. Today, we're diving into Chapter 5, Parts and Wholes, a journey of division. Honestly, if you love seeing how math jumps right off the page and into the real world, you are in for a treat. We're going to see how some of these abstract concepts actually play out in our everyday lives. It's going to be a fun one, so let's get right into it.
Okay, quick question to start us off. Would you rather have 1/2 of something or 2/4? Just your gut reaction. Now, your brain might actually play a little trick on you here, because the word quarters makes it sound like more pieces, right? And, well, the number 2 is bigger than the number 1, so inherently, 2/4 just sounds like a whole lot more. And this little perceptual conflict, that's exactly where this chapter kicks things off.
To see how the text totally dismantles this trick, let's look at Ikra and her little sister, Samina. So they want to draw, but they've only got one single sheet of paper. Ikra offers to just divide it in half. Fair enough, right? But Samina is not having it. She wants a bigger piece, and to her, 1/2 just sounds way too small. So Ikra, being the quick-thinking older sister she is, offers her 2/4 instead. And Samina? She is absolutely thrilled. She thinks she just scored the bigger piece. But did she really?
Well, to solve this little dilemma, we need to look at the foundational building blocks the chapter lays out. A half is basically what happens when an object, like that sheet of drawing paper, is divided into 2 equal parts. Mathematically, you write that as 1/2. And the absolutely crucial word here is equal. Seriously, if those 2 pieces aren't the exact same size, they're not true halves. Simple as that. Now, building right on top of that, if you take that exact same object and divide it into 4 equal parts, each part is a quarter, written as 1/4. So let's jump back to Ikra and Samina. Ikra offered 2/4. If you take 1/4, right, and put a second quarter right next to it, they perfectly equal 1/2. Boom! So mathematically speaking, 2/4 is exactly the same amount of paper as 1/2. Ikra literally just used the sound of the numbers to make her sister happy while still keeping things perfectly fair.
What's really cool here is how the chapter asks us to do this mentally. Like, if you had to physically draw a line to cut a heart and a star into perfect halves, where would you put the line? For the heart, it's pretty easy to picture a straight vertical line right down the middle, right? But the star actually gives you a few more options for that perfect symmetry. It's a great reminder that finding a half isn't just about crunching numbers, it's about physical space and visual balance.
Okay, so the source material then takes this and scales it up into a super relatable real-world scenario. Enter the Dokla dinner party. We have a character, Samita, who starts with one whole delicious dokla, and she's sharing it with her friend Vinayak. They cut it into 2 equal parts. 2 halves make a whole. Nice and easy. Samita gets half, Vinayak gets half.
But then, ding dong, the doorbell rings. Their friend Kumar shows up, so now that exact same dokla has to be divided into 3 equal parts, or thirds. And just as they're finally about to eat, ding dong, Sumedha's cousin Paridi walks in. Yup, now we're slicing it into 4 equal parts, or quarters. And you know what's coming, ding dong, the neighbor Ida arrives. So now we're down to 5 equal parts. Literally, with every single ring of that doorbell, the bottom number of our fraction, the denominator, gets bigger.
And this is just a brilliant way to show a core mathematical truth. If we map out Sumedha's chair, when it was just 2 people, she was getting a solid 1/2. But by the time 5 people are there, her share shrinks all the way down to 1/5. It's wild, right? As the guest list goes up, the fractional pieces get smaller and smaller. Basically, the larger the denominator, the smaller your physical piece of the dokla.
In fact, the text throws this awesome rhetorical question at us just to make sure it's really clicking. It asks, in which situation will Sumedha get to eat more dokla? When it's shared among 9 people or 11 people? Well, based on the pattern we just saw, 1/9 of a dokla is definitely going to be a bigger slice than 1/11. More guests literally equals smaller shares. It's just an undeniable fact when you're sharing something physical.
All right, let's pivot from sharing food to dividing up some land. The chapter introduces us to Ida's flower garden. She's got 5 different types of seeds to plant: rose, mogra, lily, marigold, and jasmine. Her master plan is to divide her garden up into 5 equal parts, so each flower type gets exactly 1/5 of the total garden space. Makes total sense.
But, real-world limitations happen, and the text uses this to teach something super important. Ida realizes she barely has any lily seeds, like definitely not enough to fill up an entire 1/5 section of her garden. So what does she do? She just takes that section meant for the lilies and uses it to plant extra roses instead.
See what happened there? We combined parts. So now the roses take up 2/5 of the whole garden. It shows that fractions are flexible. You can actually add equal parts together to represent larger portions.
Okay, moving right along. Let's completely shift gears for a second and just focus on the number 8. Specifically, we're looking at Mina and her 8 diyas, those little oil lamps. Up until now, everything we've talked about was taking one single thing, like a paper or a dokla, and chopping it up. But here, the source material flips the script. Now we're applying fractions to a group of multiple individual objects.
How do you color exactly 1/4 of Mina's 8 diyas red? Remember our definition of a quarter from earlier? It just means dividing something into 4 equal parts. So we take our total, 8 diyas, and we divide that into 4 equal groups. 8 divided by 4 is 2. Simple. So to color 1/4 of the total, Mina colors exactly 2 diyas. This is a huge shift in perspective. It proves fractions aren't just slices of a pie, they can actually be a specific amount out of a larger collection.
As we start to wrap this up, I really want to bring us full circle here. The physical act of pulling apart folded paper is just such a perfect, tangible reminder of what this whole chapter is really getting at. Fractions, they aren't just, abstract numbers floating on a whiteboard. They are deeply tied to fairness in the real world. Whether you're slicing up dinner, splitting up a garden, or just folding a piece of paper, understanding equal parts is basically the geometry of fairness.
Which brings us to the ultimate conceptual leap the source material throws our way. Without drawing any pictures, without cutting up any food, which is greater, 1/6 or 1/8? Well, if you've been tracking with us through this explainer, you already know the answer. You just have to trust that the larger denominator means the original whole was sliced into way more pieces, meaning each piece is smaller. So 1 piece out of 6 is absolutely, for sure, greater than 1 piece out of 8. 1/6 is bigger.
To finish up, I want to leave you with this really provocative question straight from the text itself. Where in your surroundings do you use fractions? Seriously, now that you've seen how tangibly a half or a quarter or a fifth impacts sharing paper, portioning out food, or planting seeds, just take a look around you. I guarantee you're going to start spotting these parts and wholes everywhere you go. Keep analyzing, keep learning, and I'll catch you on the next explainer.